Modern wars are no longer won by billion-dollar aircraft. They're won by cheap, smart, and mass-produced drones. They don't lose pilots, don't require lengthy training, and destroy targets faster than the enemy can even figure out what's going on. And if the U.S. is indeed developing a next-generation combat drone, it'll almost certainly be at Northrop Grumman, the same company that created the B-2 Spirit and B-21 Raider, machines that changed the rules of aerial warfare. The new YFQ48 project is not a one-off weapon of technological superiority, but a mass-produced and expendable instrument of war designed for autonomous action and inevitable losses. So, here's the big question. Can Northrop find the right balance between price, autonomy, and real-world combat effectiveness? The war of the future is increasingly reminiscent of the aerial duels of the 20th century and is shifting toward a competition of systems in which the winner is not the one whose aircraft is faster or whose pilot is more experienced, but the one who's able to identify the enemy faster, competently distribute tasks, and maintain combat effectiveness, even in the face of losses. For this reason, drones have long ceased to be an auxiliary element, becoming a key element of combat aviation, and the U.S. Air Force and Navy are investing increasingly more effort and American taxpayer funds in their development. But today, we're not talking about the usual reconnaissance or attack drones capable of hovering for hours over an operational area. A new class of UAV is being developed for a completely different environment, a zone of intense countermeasures, electronic warfare, deeply layered air defense, and to counter enemies whose technology generations are comparable to those of the United States. In such an environment, even the most advanced manned aircraft, while still a vital component of air combat, are still too valuable to risk. This is where the concept of human-machine collaboration emerges, where the drone doesn't replace the pilot, but merely expands his capabilities, acting as sensor nodes, weapons carriers, jammers, and expendable elements of the combat formation. This idea has long existed in the pages of books and theories of varying degrees of insanity, but over the past decade, it's managed to organically fit into the official doctrine of the U.S. Armed Forces. In fact, America took the first serious steps toward an unmanned future back in the early 2000s. However, in those years, UAVs were primarily considered for reconnaissance and precision strikes and low-intensity conflicts. The General Atomics MQ-1 Predator and MQ-9 Reaper became icons of the era, circling for hours over specific areas, searching for and illuminating targets without burning up the resources of manned aircraft. This was certainly an important stage, but it was nevertheless tailored for counter-terrorist operations in local conflicts where the enemy could not seriously challenge the U.S. air superiority. At the same time, the U.S. Navy was considering how to make drones operate in one of the most challenging environments for aviation, the deck of an aircraft carrier, amid dense traffic, open sea conditions, and constant radio interference. Northrop Grumman helped them solve this dilemma with its X-47B, leaving a mark on history as part of the Unmanned Combat Air System Demonstrator UCSD program, proving that the impossible is possible, right down to landing with a resting gear. The turning point came towards the end of the 2010s when the Pentagon increasingly began to mention conflicts with peer adversaries. China and Russia were actively developing their own air defense systems, electronic warfare assets, and fighter aircraft, making potential conventional operations against them increasingly risky. In response, the U.S. Air Force began to explore ways to maintain the initiative without exponentially increasing costs. Thus, the Skyborg program emerged, not as a specific device, but as a well-thought-out architecture. Its goal was to create an autonomous brain center capable of controlling multiple UAVs in conjunction with manned fighter jets. In fact, it was the Skyborg that became the next step on the path to collaborative combat aircraft, CCA inextricably linked with the NGAD fighter and mentioned in literally every article or video about it. But CCA is no longer an experiment, but a highly practical program aimed at the widespread introduction of semi-autonomous combat drones into U.S. aviation in the 2030s. The key word here is collaborative, as the drones will not simply perform assigned missions, but also interact with pilots, instantly adapting to battlefield conditions. Drones solve several important problems for aviation in any country in the world. Scalability. They can be used in groups distributing functions. Survivability. The loss of an individual device does not mean mission failure. Flexibility. The same drone can perform completely different roles, reducing the risk to the pilot. The person remains in the control center, but at the same time far from the zone of maximum danger to his life. All of these points are particularly important for the U.S. Navy. After all, the vast distances of the Pacific region, the limited number of aircraft carriers, and the high cost of carrier-based aircraft made the loyal wingman concept for UAVs practically inevitable. Meanwhile, the U.S. Air Force was running into the arithmetic of a major war. Expensive aircraft couldn't be multiplied as quickly as desired, much less train pilots for them. Therefore, the service also conceived the idea of affordable mass production, which envisions a multitude of aircraft smart and useful enough to augment manned aircraft, but inexpensive enough that their loss wouldn't undermine the overall strategy. Northrop Grumman, which donated one of the most effective unmanned reconnaissance aircraft, the RQ-4 Global Hawk, to the U.S. Air Force and NATO Air Forces in the 2000s, volunteered to help them with this issue. However, the RQ-4's success quickly revealed its limitations. It was vulnerable to advanced air defenses, dependent on stable communications channels, and virtually useless in a rapidly changing combat environment. When the American services realized that future conflicts would take place not over weakly defended regions, in the range of modern air defense systems and electronic warfare systems, the concept of a high-altitude observer was no longer sufficient. The X-47B, while never mass-produced, changed the landscape of what combat UAVs were capable of: autonomous takeoffs and landings on aircraft carriers, integration into deck operations, and complex human interaction scenarios. All of this laid a solid foundation for the next generation of projects. Most importantly, the company gained experience in creating an unmanned platform capable of operating independently in the harshest conditions rather than simply performing tasks remotely. So when Northrop and their subsidiary Scale Composites announced the development of a new combat drone, the YFQ48, also known as a Talon, experts were waiting with bated breath for details. In reality, the YFQ48 was a result of Northrop's failure in the first phase of the U.S. Air Force's CCA development program, Increment 1. The company presented a project that proved larger and more expensive than its competitors, the General Atomics YFQ42 and Anduril YFQ44, which were selected for further development under Engineering and Manufacturing Development, EMD. However, at the time it was still known as Project Lotus. After a minor rebranding and a significant redesign, Project Talon became significantly smaller, simpler, and cheaper, shedding 50% of its parts and 1,000 pounds compared to the original design. This was made possible by the extensive use of composite materials in the drone's construction, which not only reduced its weight, but also reduced assembly time by approximately 30%. For convenience, all CCA program applicants have received the general designation YFQ, where Y stands for prototype, F for fighter, and Q signifies drone. This indexation at least hints at the fact that they're viewed not as auxiliary platforms, but as full-fledged participants in air combat, albeit in a slightly different role than classic manned aircraft. Northrop and Scale Composites were able to get the Talon ready with great speed, with the project taking about 15 months from authorization to wait on wheel status against an already ambitious target of less than 24 months. The point here isn't so much about speed, but rather the meta-design of making combat drones that can be built quickly and scaled just as quickly. For now, Northrop is avoiding any details about the UAV's engine, operational range, payload, altitude ceiling, or cost. However, photos and details snatched from various events allow us to at least describe the outer shell of this drone's iron core. The YFQ-48A features a lambda-shaped wing, a veil, a trapezoidal air intake on the upper fuselage, and a shovel-shaped nose. It also features a vertical stabilizer running along the nose, and panels with serrated and trapezoidal edges are visible around the perimeter of the aircraft. Nestled between the tailplane is a round, semi-recessed exhaust with a single turbofan engine, and the drone itself, like most other Northrop projects, was designed with a strong emphasis on stealth, especially from the critical forward angle. The bottom is not flat and features a large panel with jagged edges that'll almost certainly end up as a weapons bay, though the company hasn't officially announced this feature yet. 3 air quality probes protrude from the nose, which is quite typical for this configuration at this stage of development. 3 small domed antennas at the aircraft's forward upper fuselage and another atop the intake, as well as what appear to be for cane vertical aerials. Also visible are widely spaced single-wheel landing gear under the wing, which retract into UAV, and a small opening that could house a camera for flight testing and general navigational purposes. Northrop itself claims the landing gear was borrowed from an existing aircraft design, but declined to specify which aircraft it was referring to. The team responsible for the YFQ48A stated that Project Talon is cheaper and better than its predecessor Lotos in every respect and significantly different from the company's proposal during the CCA Increment 1 selection. Although in its current form, this promising drone is not yet fully adapted to perform specific tasks. It was designed for use in a variety of modes, adapting to customer requirements. The development was a 50-50 split between Northrop Grumman and Scale Composites with the Prism Autonomous Suite providing the brains of the vehicle. The YFQ-48's maiden flight is planned for this year, but the team is not yet sharing details about where and when exactly it'll take place. One thing's certain, the CCA program is well underway and Increment 2 is in full swing, meaning that when the 6th-generation fighters and new stealth bombers enter service with the American forces, it will already have the worthy support of 1,000 new drones from various teams ready to carry out any mission. Do you think Northrop Grumman's ambitions can be packaged into a cost-effective yet powerful drone? Let us know in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.